This is the second webinar on advanced renewable diesel, and during these webinars we'll be exploring the opportunities that sustainable renewable fuels have in decarbonising not only road transport but also the aviation sector as well. My name's Gloria Esposito and I'm Head of Sustainability at Zemo Partnership, and I'm joined this morning by Gaynor Hartnell, the CEO of the RTFA, chairing the session.
Great, thank you very much, Gloria. And yes, my name's Gaynor Hartnell, and I'm delighted to be working with Gloria and her colleagues at Zemo Partnership to put on this series of webinars. Yes, the slides, not all of the slides, but most of the slides will be available after the event on the Zemo Partnership website. So I'm going to be doing the brief list of introductions to start with, a few opening remarks, and then I'll invite each of our 4 speakers to talk for 15 minutes. I'll take questions for the speakers at the end of that, during the panel discussion. So I'll ask some questions of the panel to get things going, and then Gloria will be reviewing the questions. So make it clear who your question is directed to, or if it's a question for all, say question for all. And Gloria, I'm pleased to say, will also be doing the timekeeping. So yeah, so I'm doing the renewable diesel webinar, and I think in many ways it's got the most interesting of challenges for all of the different renewable fuels, given the great variety of ways there are to make renewable diesels and all sorts of aspects to do with feedstocks and how they manifest their characteristics sometimes into the resulting fuel. There's blending standards issues, there's additives and how they can change properties. So it's got a great deal of richness, this theme. Of course, when it comes to transport fuels on roads, diesel's expected to be on its way out. DFT is intending to consult on ending the sale of new diesel HGVs, and very recently it just published its consultation on ending the sale of new diesel buses. But however, on the plus side, it's a fuel that's really very hard to beat, given its excellent energy density properties. And you could say as well that more feedstocks are becoming available for producing into renewable diesel, because as the grid decarbonises, some of the feedstocks that might have otherwise gone to, say, power generation can now be looked upon as going more constructively to renewable fuel production, because more greenhouse gas is saved by that route. As diesel kind of moves through different transport sectors, as it declines in road transport and moves over into maritime and moves over into aviation, these kind of fuels will slowly be displacing fossil fuels and may indeed be enduring solutions in some of these transport sectors. So if there's any delay in the rate of electrification, which of course one hopes there won't be, but if there is, it makes the role that these can play all the more important in the future. And of course they are what's saving much of the carbon in decarbonisation today, and so fuels do deserve a lot more recognition. So all in all, we're progressively removing the fossil component, and it's the fossil component of transport fuels that's a problem, not the fact that they're liquid fuels. So those are my few opening remarks. So let's hear about the various ways this could be done. And first of all, we've got Chris Brookhouse, who's the Director of Infrastructure at Greenergy, where he's been for the last 6 years. And prior to that, he's had roles both upstream and downstream, and significant experience with gasification and power development and other capital development projects. He's worked in London, New York and Singapore, and he's going to tell us about the project in the Thames Enterprise Park that Greenergy is developing. Over to you, Chris.
Thanks, Gaynor, and morning, everybody. As you've introduced, I want to use the next, make sure I don't go over my 15 minutes, but to give you some details on our project on the Thames. So you'll probably see there, for those that know, that's the old Corriton refinery location in the bottom left. I think this picture is a couple of years old. DP World Port, that's grown a little bit. We've we also have our own asset as Thames Oil Port. But in the centre there, where the old refinery you can see is demolished, is 400 acres of land that we're redeveloping as Thames Enterprise Park. So I'm going to use the presentation to give you an introduction to our project called GTT. You go to the next slide, please. So any presentation probably wouldn't be the same unless I use it to give a corporate introduction as well, if you don't mind. So just a few words on Greenergy. Apologies if you know this, but obviously, although originally, very much a UK business, we've continued to grow our business globally. Obviously, our significant footprint in the UK, but also now North America, Brazil, and you'll see on the next slide, reaching out into parts of Asia. So we're obviously an integrated end-to-end supply chain. We own quite a significant amount of infrastructure, and obviously we have quite a significant UK footprint with around 30% market share. Over the last few years, we've extended downstream and have a greater presence in retail and have our own retail estate, significant presence in Canada, as well as we have the brand in Ireland under Invenergy. So we've got quite a significant retail presence, and obviously we've got a significant waste-based biofuel production business, which we'll touch on the next slide, please. So again, just by way of introduction, we've got 3 biodiesel facilities based, 2 in the UK, one in Amsterdam. That's got a combined production capacity of 650,000 tonnes. As you also see on the sketch, we vertically integrated, because obviously all 3 of those biodiesel facilities operate on used cooking oil. We've extended our supply chain from Europe to both the USA and into the Middle East and out into the Asia Pacific region. And obviously, as you're all aware, not only has the RTFA got increasing blending obligations as represented in the bottom right-hand chart, that the development fuel obligation was added in 2018. That mandate grows to 2.8% currently out to 2032, and I think we would certainly, as Greenergy, we would expect it to increase as the industry proves that it can be developed. I think there's a question mark which we may come to later in terms of the implication of 2032 and whether that also can be considered to be extended. Anyway, next slide, please. So a lot of words on this slide, but as all things, the obligation is there, and this obligation I'm referring mainly to development fuels, but it's obviously very much an opportunity.
I mind if you listen to me. Yeah. How long is it?
Oh, it's just a.
Can you put your mics on mute, please? Thank you. Sorry, Chris.
What is it?
That's fine. One day we'll get used to working everything on Zoom. Sorry. So the obligation. So it's obviously providing the incentive for industry to find solutions. I'm not going to go into the feedstocks and the products and the pathways. Again, I think we all probably know that, or we can certainly read the legislation, but probably again, as we've put in the bottom left-hand corner, whether this turns out or not, but there's a significant volume that's required to meet the obligation. Obviously, that's driven on your forecast for transportation fuels that it's displacing, and depending on where the market clearing price for certificates and fuels to meet that obligation, the 80 pence per certificate creates headroom for significant opportunity. So let's just talk to the right hand side in terms of how Greenergy sees the opportunity. Obviously, at the moment, there's very little, supply. A lot of projects in development, probably between 23 and 25 coming on stream. But given where that buyout currently is, pretty much at 80p currently, that does provide that incentive. So, Greenergy obviously has an obligation. We're very, very keen to enter long-term offtakes to projects that comes forward, but we're actually proactively spending both money and resources developing our own projects. And so when we're looking at projects in this space that meet the requirements of the development fuel obligation, I've just listed here some of the items that are important to us as we review. So when we look at technology, we are agnostic, but we need to be comfortable that they are proven technologies applied to waste feedstocks and ultimately can be bankable, and I'll talk about what that means. Then as far as commercial, then we look at projects that they need to be what we call de-risked and can support and have long-term contracts in terms of feedstock and other offtakes. And then as we look at the economics, what we look at is the required certificate price that the project needs, or rather the premium required of the fuel over the fuel that it's displacing, and that has to be looked at on a global basis to be competitive. And what they all drive to is that hopefully they can secure project debt and equity. So we do have a funnel of various projects. What we've listed here is probably some of the pathways that we're pursuing. So what I'd like to do, go to the next slide, and we'll talk about I think GTT. So GTT is our tyre pyrolysis project that hopefully some of you saw. We issued a press release at the beginning of January when we started FEED. Again, for anybody who develops projects, FEED is a pretty significant capital commitment to progress the project. We do at this stage hopefully believe we've put together a project which meets those objectives I set out on the previous page. So in terms of the parties here, it combines ThyssenKrupp's pyrolysis technology and Holder Topsoe's hydrotreating, their Hydroflex technology in two hydrotreaters. There's two major parts to this project. So the first part, as you can see, is the tyre pyrolysis combined with hydrotreating, and with the intention of that's producing development fuels, drop-in transportation fuels. It does produce marine, but that's currently not obviously classified. And then as a byproduct, we recover carbon black, which either can go back into the tyre manufacturing process, so it is circular and positive from that perspective. And then secondly, we've got a separate UCO hydrotreating stream that at this stage we're not communicating whether that goes into the HVO or SAF. We need to to continue to see which is the logical route for that. Some of the timelines: kicked off FEED. If all things go well, we'll aim to reach our final investment decision and financial close end of next year, and into construction with target commissioning at the end of 24 into 25. There's some volumes at the bottom of the chart. I think as far as the development, we may build the project in phases, but I think our goal is to go to the end of phase 2 in one go with 500 tonnes per day of tyre feedstock. So if we can go to the next slide, please. So, project will be located at Thames Enterprise Park, as I mentioned earlier, part of the old refinery. So that is a 412-acre brownfield site, pretty good location relative to offtake. You may have picked up, there's a lot of news recently in the various free ports around the UK, and TEP was announced as part of the London Thames free port. And in terms of what the location provides for our project, obviously logistics pretty important in road, rail and sea. It's pretty good local waste tyre market in the southeast. Side is connected into the UCOP and CLH pipelines, so we think that's pretty advantageous with regards to blended product for the SAF. Benefits from fuel import and export, and there are a number of other both waste to energy and waste to fuel projects that are likely to happen on site. So there'll be other synergies. Next slide, please. So a lot of circles on this chart, not many words, but let me try and expand on what I mentioned a few slides ago in terms of how we think about project development. So we do take a project finance approach to structuring these projects, and that's partly might describe the way you think about doing projects. So what does this mean? So as Greenergy, what this means is we aim to remove market risk from the projects with our goal of accessing lower cost of funding. That means the cost ultimately that debt and equity needs to return. So Greenergy provides the long-term offtake to underwrite the project, and that in turn means a back-to-back contractual structure to cover feedstock, capex, amortization, O&M, and that necessary return. What it does leave, though, is it leaves the risk of the technology and performance in the SPV, the special purpose vehicle, the project company. But because of how we approach the technology selection, that we assume the EPC will stand behind the technology, certainly up through construction and the early stage of operation. So, and by also us as Greenergy taking an active role in the development of the projects, then we can make sure that chain works, and we ensure that the project is as viable at, coming back to the most important thing, the lowest cost per cert. And we also think as well, given the moment the legislation is only out to 2032, it's critical that we move through the right stages with as much speed as we possibly can to get these projects into operation. Next slide, please. So last slide, probably just to summarize. So we obviously do believe we've got a good base in renewables, and we're progressing a pipeline of advanced renewable projects. So they're both drop-in fuels. They're also focused on SAF, and we're also interested in bio SNG. And then just restate, so obviously as a primary interest, we're interested in underwriting and entering offtake for fuels, but we can also be involved as developer and co-developer if it's beneficial to the project. We are in the process of establishing what we call a renewables platform, which increases our access to funding to hopefully progress further projects. Again, because if anybody's involved in project development, it's the minority that get to financial close, because they're difficult when these are 300, 400, 500 million pound projects. There's a lot of of issues to progress them further, which we'll probably talk in the panel. So it's good and important to progress options. And then the last comment, which probably is obvious, but I think we need to be very mindful of, because of what is coming, and probably as you look at waste, then the commoditization of those wastes as we go forward in terms of the lowest cost source and the highest value market when you look at the processing to fuels. So I think that's probably me done, and probably just in time.
Excellent. Thanks very much, Chris. I think this shows that in many ways there's just as much innovation in the actual kind of way that the project is developed and financed as there is in the technology involved in actually producing the fuel itself. Just before moving on to Simon, you mentioned about the obligation, the legislation only going out to 2032. You're right in that targets only increase out to 2032. That there is actually no end date, but it's not terribly clear to many people that it does go beyond 2032. But we need the targets, of course, to increase beyond 2032 as well. So just in case anyone might have got the wrong end of the stick there. Right, excellent. So now we move on to Simon Holt of Phillips 66. Simon's job title is Manager of European Value Chain Optimisation, and he's responsible for developing the company's UK integrated strategy in line with the UK government's net zero goal, optimising across the value chain from feedstock sourcing to product placement. And he's a chemical engineer, and he's been at Phillips 66 for the last 22 years. Simon.
Thanks, Gaynor. Good morning, everybody. Thanks for the introduction. So today I will talk about Phillips 66 and our production of low carbon liquid fuels, not just diesel, but all the other products we make. But diesel, I guess, is the main driver. Next slide, please. Again, the obligatory company overview. Phillips 66 predominantly operates in the US with a large midstream pipeline business, which was formed after the split from ConocoPhillips in 2012. We have a JV chemical company with Chevron, that's Chevron Phillips Chemical. We operate 12 refineries, including Humber Refinery in North Lincolnshire. And we also have a share in the Myro Refinery in Germany, which supports our jet-branded service stations in Germany and Austria. Our global marketing presence sells fuels worldwide on a wholesale and retail basis under the jet brand in the UK, Phillips 66 brand, Conoco brand, and the 76 brand in the US. Next slide, please. So one area of our business that goes under the radar for the most part, and it's an area that I'm particularly proud of as we face the dual challenge of climate change and growing energy demand, is our Energy Research and Innovation Center in Bartlesville, Oklahoma. This huge 440-acre facility is a home to a team of research scientists and engineers, and they're focusing on sustainability technologies to help address the massive challenge that we face. On renewable fuels, Phillips 66 has developed patented technologies to produce renewable fuels from a variety of feed sources. And the technical support from Bartlesville has been essential for the successful implementation of co-processing at Humber Refinery. We continue to advance our opportunities for increasing our low carbon liquid fuel production through co-processing of different wastes, evolving and adapting our refinery's processing capability to cope with different and difficult to process feeds. Next slide, please. So Humber Refinery in North Lincolnshire, it's one of the most complex and energy efficient refineries in Europe, and the only refinery in Europe that produces specialty graphite coke for use in electric vehicle and consumer electronic batteries. And it's also used for steel recycling. Humber is also leading the way in low carbon liquid fuels production. We were the first refinery in the UK to produce renewable fuels at scale from waste when used cooking oil was introduced in 2017.
I swear there was like, because I remember the first one, which was like, what you
Excuse me, can you switch your mics off? I'm sorry about that. Simon, do you want to carry on?
You're actually muted yourself at the moment.
Okay. So yeah, the refinery, it's a complex facility. We've got 4 cokers, 2 crackers, hydro processing capacity, and so it makes it ideal for processing a variety of different feeds, and we can inject those feeds at various parts of the process depending on the quality of the feeds. So used cooking oil, UCO, is co-processed alongside crude oil-based feedstocks, and as we increase our UCO processing, we back out the fossil feeds from the refinery feed slate. Last year we installed a new unit, which you can see in the picture, rolling into the refinery on a nice sunny day, and that allowed our UCO processing to be trebled at the end of last year, and we've got plans to increase that further this year. So the renewable products we produce from waste streams we process meet the existing product specifications, and the products we make go into the propane market, gasoline market, kerosene, home heating, and diesel. Next slide, please. Co-processing doesn't come without its challenges, and the journey has certainly been a case of 2 steps forward, 1 step back all along the way. Feedstock availability will become an increasing challenge as new capacity comes online in Europe, US and Asia, and the winners in the space are going to be those that can process the most difficult to process feeds. Feedstock quality variability is a concern to any manufacturer, and we've developed our feedstock sourcing, supply chain logistics and blending capabilities to minimize the impacts of this. At the refinery itself, corrosion, fouling, catalyst poisoning all need to be carefully monitored and managed. Pre-treatment of feeds and intermediates is essential. On the economic side, RTFA provides some financial incentive, but as Chris was saying, further support mechanisms are required for the development of advanced biofuels and development fuels from waste, particularly in support of the production of low carbon liquid fuels for aviation and other difficult to electrify sectors. Society has significant waste problems to solve, and converting waste to fuels is key to progressing the energy transition at the same time as cleaning up the world. In terms of economic cost and cradle to grave greenhouse gas emissions, the most efficient way of producing low carbon fuels is through utilising existing refinery and product supply infrastructure, processing multiple waste streams to produce products which are identical to the fossil equivalents, the Humber refinery, we're also able to shift yields between different products through the re-engineering of our processes as demand for road fuels declines over time, but aviation and shipping demand remains strong. Next slide, please. So Concarway developed this model for the refinery of the future. UK PIA, Fuels Europe have developed this further in their future vision documents. A refinery is a complex hydrocarbon upgrading facility producing liquid fuels at scale. In the case of Humber Refinery, that's 30 million litres a day of fuel. Multiple processes remain applicable, whether the feedstock is crude oil, waste, or biomass. We all know multiple solutions are required to decarbonise all sectors of industry and transport. Collectively, the fuels manufacturing industry can use our expertise and multi-billion pound existing UK infrastructure for the transformational change required to achieve net zero by 2050. And next slide, please. It's the last slide, I think. So here are just some examples of projects that Phillips 66 is working on to achieve the net zero target. We've got the Gigastack project, which we believe is the best opportunity to provide renewable hydrogen at scale. We're directly connected to the Ørsted Hornsey 1 and 2 substation. It will allow industrial scale green hydrogen deployment at the refinery and also for supplying a transportation fueling hub. The electric vehicle supply chain in the UK, as Europe's only producer of specialty synthetic graphite, including graphite electrode battery coke, we feel that this is a critical component in the lithium-ion battery supply chain. Synthetic graphite demand is forecast to grow from 60,000 tonnes a year in 2020 to 600,000 tonnes a year in 2030, or from 3 million EVs to 25 million EVs a year by 2030. And Phillips 66 is supporting the development of a UK-based electric vehicle supply chain. Humber Zero, Humberside region, it's one of the UK's most industrialised, largest CO2 clusters. The government recognises that decarbonisation needs to be achieved without offshoring emissions or jobs. And the Humber refinery and the local area offers the UK's best economy of scale and lowest cost CO2 abatement. And just finishing on low carbon liquid fuels. In summary, Humber refinery, first in the UK to produce finished fuels from waste. We've trebled our processing capacity at the end of last year. We're working on development fuel production with trials ongoing. However, low carbon liquid fuels remain a government policy gap in the UK. It's the lowest cost transition fuel for most sectors, and we can utilise existing infrastructure as we proceed on the journey to net zero. Thank you very much.
Simon, thank you very much. Excellent presentation and some very good points made. And it's nice to see geographically we've moved from the Thames to the Humber. Yeah, so I think moving on, we've now got Olivier Macé, who is not associated with any particular project, of course. He's the owner and principal of Broadmanor Consulting. He's that's offering expertise across the biofuels value chain. He previously was with BP for 31 years, and the last 15 of that he was looking after renewable fuels, culminating in him being the biofuels director for Europe downstream refining, supply and marketing. So Olivier, sorry, over to you.
Okay, thank you very much, Gaynor, and good morning, everyone. So, Gloria, if I could have the next slide, please. So we're talking about going beyond the blend wall, and I'm sure many of you will be familiar with the blend wall on this call, but for anybody who is not, the blend wall is effectively defined as the maximum blend of the conventional biofuels, so ethanol into gasoline and FAME into diesel, that is allowed by the fuel specifications for the retail fuel specs, so EN 228 for gasoline and EN 590 for diesel. So effectively, you can translate that in the maximum target for renewables that can be met using those two conventional products, ethanol and FAME, on a single counting basis. And I've done a little bit of very simplistic modeling here using the UK. Now, because the UK, like many European countries, has got a mixed target for renewables where both the gasoline and the diesel play into the same overall target. If you want to translate the blend wall into a maximum target, you have to understand the relative proportions of the two products. So I've used 2019 data for the UK, 16 billion litres of petrol and 30 billion litres of diesel, roughly 1/3, 2/3. And you can see how the blend wall is positioned, what the blend wall means in terms of targets in percent volume, again, on a simple single counting basis, depending on how the spec evolves. So today the specification is, of course, B7 and E5. It will soon be B7 and E10. And by the way, well done to all those who participated in making that happen, including yourselves, Gloria and Gaynor. I think it's a great move. And I think we can expect that these maximum specifications will carry on being tested. I mean, certainly what we see in the UK is the emergence of high blends like B30. So my middle case is B7, E10, but also a certain proportion of B30, up to 10% B30, could be 3% of B100 just as well. I've done a case for B10. Now, I know B10 is not a reality today, but there is quite a bit of noise about B10. There are some lobby groups that are pushing quite hard for the FAME spec to move to 10%. And there are some car manufacturers, especially the French ones, who have declared their engines compatible with B10. And at the end, I have a highly speculative case, which may be a long-term destination for those specs of B10 on the diesel side and E15 on the gasoline side, but we're a long way from that right now. We'll just celebrate getting to E10 for the time being. So that's how the blend wall works, and that's how it can be translated into a certain level of renewables penetration in road transport. How do you go beyond the blend wall? Well, of course, the simplest way to go beyond the blend wall is to use double counting in countries where it exists. And certainly double counting has been a massive signal in this country, and most of the biodiesel in this country is double counting. High blends, I've already mentioned high blends, B30, B100. E95 has been considered by companies like Scania as a truck fuel. E85 for gasoline, of course. But when you've exhausted all that you can do, then you have to use drop-in fuels, which are fuels that allow you to go beyond those specifications of B7 and E10 fuels, biofuels that you can blend in higher quantities. So drop-in fuels, if we can move to the next slide, please. Drop-in fuels are essentially today, they're hydrocarbons. So they are molecularly the same molecules that some of the molecules that comprise fossil diesel, and therefore they're fully compatible. You've got a number of manufacturing pathways to create drop-in fuels, so hydrocarbon biofuels. The better known, I guess, today is HVO, so hydrogenation of lipids, fats, oils, and greases. But you've got a number of other ones like gasification of biomass, and then reforming the syngas from the gasification into hydrocarbon in the so-called Fischer-Tropsch reaction. And in the fullness of time, we'll probably see power-to-fuels or e-fuels, which are green hydrogen from the electrolysis of water combined with capture carbon to reform hydrocarbon chains, to reform or they're not bio, but synthetic hydrocarbons. Drop-in means they can be blended without limit. When I say without limit, it's subject to their quality as a blend stock, just like any other blend stock coming from refinery units going into the gasoline pool or the diesel pool. You can only incorporate those fuels to the point that they make sense vis-a-vis their properties in the finished product, to meet the finished product spec. And GHG savings depend primarily, I would say, on the type of feedstock that is used, to a lesser extent on the manufacturing process, but very often the feedstock, the way it's cultivated or the way it's acquired, if we're talking about the waste and the emissions that are avoided, that has a major role in deciding the greenhouse gas savings of the fuel. Most likely applications today appear to be for jet and diesel, although that's not universally true, and there is also bio-naphtha and biogasoline from various processes that can be used in the gasoline pool. So if we move to the next slide, so looking at HVO as probably the most prominent drop-in fuel today, as a diesel blend stock, how does it fare? Good in some ways, a bit less good in others. So the cold properties tend to be poor unless the product is isomerized, which today a lot of the standalone HVO plants have got this extra step of isomerization of the product to improve the cold properties. Cetane is high, which makes it a really good blend stock in terms of hitting the cetane spec for finished diesel. Density is low, and in fact it's lower than the EN590 minimum density, so it needs to be blended with higher density components for the diesel to be on spec. And sulfur, it's virtually zero sulfur, and therefore it's a very good blend stock to help meet the ultra low sulfur diesel 10 ppm specification. So all that is really preamble. If we can have the next slide, and we're now getting to the crux of the issue, which is how do we get to a really low carbon diesel? Now, what do I mean by a really low carbon diesel? If we think of the carbon intensity of the fuel in the UK today, I would say it's probably around 6%, because 6% was a specification last year for road transport. And I would say today, probably the fuel is somewhere around the 6% mark in terms of the carbon intensity compared to fossil fuel carbon intensity. Where do we want to be by 2030? Maybe 15%, maybe 22%. I've picked 22% because it happens to be the German proposal in their draft legislation for 2030. But how do we go deeper than that in terms of greenhouse gas reduction in carbon intensity? How do we get to a fuel with 30% carbon intensity reductions, with 50%? I've done, again, some very simplistic modeling using only 4 components: a crop biodiesel at 70% greenhouse gas savings, a waste biodiesel at 90%, a crop HVO at 60%, and a waste HVO at 80%. And the result on the next slide, I mean, none of this is rocket science, by the way. The results are fairly predictable. B7 or even B10, if it happens, doesn't get you very far towards deep decarbonization, towards creating something that I would call a ULCD, an ultra low carbon diesel. The choices for an ultra low carbon diesel are twofold: either high blends like B30 or B100 or R100, which is 100% HVO, but those high blends are not do not meet the EN590 specs. So it's difficult to introduce them as a retail grade. If you want something that you can introduce as a retail grade on the petrol stations, because it means the EN590 spec, you're really looking at combining as much FAME as is possible, so B7 today, with significant quantities of HVO or significant quantities of renewable diesel. So to get to 30% CI reduction in my model, you need 30% HVO and B7. To get to 50% reductions, you'd need B7 plus 55% HVO. So we are really looking at co-blending HVO and FAME. How do they co-blend? If I can have the next slide, please. They co-blend pretty well. I mean, HVO, again, is a hydrocarbon. So blending FAME into HVO roughly is similar to blending FAME into fossil diesel. There are a couple of nuances, though, because HVO is paraffinic. What it does is when you have a hydrocarbon side of your blend, which contains a lot of HVO, it's going to directionally reduce the amount of aromatics in that hydrocarbon blend. And there's a few things that need to be taken into account. So there are things where HVO and FAME are very good together and very synergistic. HVO is low density, FAME is high density. So actually having FAME in the blend helps with the low density of HVO. Same thing with lubricity. FAME is high lubricity and therefore removes the need for or diminishes the need for lubricity additives when you co-blend. But there is a couple of things that need to be carefully looked at. Because HVO is paraffinic, having a lot of HVO in your hydrocarbon side of the blend reduces the solubility of something called SMGs. And those SMGs, which is saturated monoglycerides, if there are a lot of saturated monoglycerides in your FAME, it can impact the cold start operability and create filter plugging issues. So depending on the FAME, the type of FAME that you use, you have to be a little bit careful if you have a high proportion of HVO or paraffinic renewable diesel in the finished blend. And on cold flow properties in general, so the cold flow properties of the HVO depends on the type of HVO, whether it's isomerized or not. Of course, same thing for FAME. You have different grades of FAME with different cold flow properties. So clearly the blend will have to take into account of all of that. But also the cold property additives, you need to be a little bit careful because they tend to be manufactured, they tend to be designed for fossil diesel. And again, fossil diesel will have more aromatics compared to a hydrocarbon, including a lot of HVO or renewable diesel in the blend. So to conclude, no showstoppers in blending HVO and FAME, and some good synergistic attributes in some important respects. So if I can have the final slide, just to conclude, as the mandates increase across Europe and in this country, as the targets increase, drop-in fuels like HVO are going to be increasingly needed to provide lower carbon fuels, which are completely compatible with the existing park, and which means the specs, the retail specs, EN228, EN590. HVO and other renewable diesels are hydrocarbons like fossil diesel, but that doesn't mean that they fully meet the diesel specification. I mean, density, for example, HVO density does not meet the diesel specification. And if we are looking at creating those ULCD products, ultra low carbon diesels, it's very likely that we are going to have to involve significant amounts of drop-in diesel and blend that drop-in diesel with FAME, and both have an important role to play. They're complementary in delivering the carbon intensity reductions that we're looking for in these very low carbon fuels. And the blending recipe, with a little bit of care in how we blend them, they can blend well to optimize the quality of the finished diesel, and again, maximize the carbon reductions. There are some big issues there that we didn't have time to cover today. One is feedstock availability, and specifically when we're looking at HVO, feedstock availability for waste, fats, oil, and greases. And another big issue is, of course, the scalability and the price point for those products, for this ULCD product. Needless to say, introducing a grade like that at the retail station only makes sense if you can present it at a price point where the consumer is prepared to buy it. And we've got probably spend a day on that, never mind 15 minutes. But for now, I'll stop there, and I look forward to the discussions later.
Thank you very much, Ollie. Yes, the discussion, and you've got some questions as well. Yeah, I very much enjoyed that. I think it's really good to show, you know, there can be huge amounts more that can be done. We really need some ambition from the government in what can be done to decarbonise fuels, and sooner rather than later. You mentioned B10 and wanting that to become a reality. Of course, that's a really important thing. I just wanted to put a plug in for the Zemo high blend biofuels report, which talks about some of the blends you've talked about today, Ollie. And yeah, the point, yeah, when you've exhausted everything else, this is what more you can do. So sometimes there can be some sort of adversarial relations between biodiesel and the paraffinic diesels, which really I don't think should be there. And I think your talk was very helpful in that. Right, so we've now got the final speaker of this morning, and I'd like to introduce, when I find my notes, yes, Martin Atkins, who's the Chief Executive of co-founder of Lizard Technology Ltd, which is a Queen's University Belfast spin-out company where he held the chair of chemical innovation and sustainability. And he focused on core platforms in clean energy technologies and recycling. Spent 35 years in the oil industry and the gas industry, and his current focus is on driving innovative technologies towards commercialisation and deployment within the sustainable energy and chemical industries. So over to you, Martin.
Thank you very much, and it's a great pleasure to meet you all on this call virtually, at least. I'm going to do a slightly different format for my talk today. I'm going to be sharing some details of the products that we're making and the strategy that we're making these biofuels from waste biomass. So I should be really showing you and illustrating work in progress on the biodiesel and great progress towards the SAF as well. So just a little bit about who we are. We're a partnership with Abundia Global Impact Group in the US. It's a family office. We're actually the research arm of Abundia Group going forward. We've been working with a company in the US since about 2015, 2016. And we're actually in the final stages of acquiring that company as well. So we're rolling out this technology in the UK, and I'll come on to the technology in a little while. But I just wanted to add for this audience just a comment that we're focused on diesel here as well. But as we've been moving out this process and the products, we're finding a lot of interest in domestic heating fuels as well, because they're actually under great stress from emissions control. And in a lot of very remote locations where people are on heating oils and oils for domestic heating and generator backup as well, I think these fuels have got a great opportunity in there. So the strategy that we've adopted on this technology, my background is in the oil and gas industry, a bit like Olivier. I spent 3 decades in BP, my favourite company of all time, and we really understood supply chains from day one. And what we've done in this process and this project is to bring the whole supply chain together. So we work with one of the global number one, actually number 2 biomass producer on the globe. We do the technology ourselves, and we work downstream with a lot of the contacts that we've had in the fuels industry. And at the end of the talk, I'd just like to acknowledge the contribution from a lot of those players. So if we go on to the next slide, I'll just explain a little bit more about the technology. So like many people on this call and in the audience here, biomass pyrolysis has been around for a long time, and there's always been problems with it. Notably, there's lots of oxygenated materials, lots of myriad of products, and it's been very, very difficult to actually get a product that you can upgrade economically in a refining environment. So this process is quite different. There's two elements of this process which I draw attention to immediately. One is the economics of biomass processing going into fuels is challenging at the best of times. But if you've got byproducts that are really high value in this arena, it does help with the overall economics. So our process, which is taking waste biomass, which we all go through the ISCC accreditation and compliance on with our feedstock partner. When we move that technology forward, it goes through preparation and drying, it goes through pyrolysis, which is the primary conversion process in a very novel reactor system. And that also produces, in addition to the distillate hydrocarbons, it actually produces a very valuable component, which is graphene. About 90% of our biochar out of this process is actually graphene. So Simon was introducing some materials as well about graphite from various products. This is graphene, so it's a very valuable product that comes out of the material. So we actually then upgrade those materials with using conventional hydrocarbon upgrading technologies that we see in the refinery. So isomerization, HDS, hydrogenation. So we get a lot of standard technologies that are coming together to take those hydrocarbons through to finished products, and we can fractionate them, we get them analyzed. And the key thing with all of this, which is some of you who worked on biomass pyrolysis before will know that oxygen in the biomass has been very difficult to get out. Our system is oxygen free, which we'll come on to in the future slides. If we go to the next slide, please, I'll just talk a little bit more about the feedstocks that we've used. So we've been working with this company since 2017, when the first what we call crude diesel came on stream at 7.2 million gallons. And there's just some pictures there to show you actually how it comes off the plant. So the middle one is actually what the liquids look like, and probably some of you that worked in biomass pyrolysis previously will be very familiar with that colour. Just by simple filtration of that, because there's fine carbon in there as well, we get some products which are reasonable in colour prior to distillation. That facility was run at 7.2 million gallons since 2017, and we're now bringing the first UK plant on stream, which will be 20 million gallons, and a further scale up of the US plant to 20 million gallons. We've used a variety of feedstock wastes in there, and I've just listed a few there. As we go forward, obviously waste biomass, as we've discussed previously in these talks, is one of the key targets for us. So if we move on to the next slide, please. So what I'd like to do is just remind people of the specs for the Jet A1 and the specs for renewable diesel. And in the table below, I've actually put the spec of our product, which is very much work in progress, in red. So you can see all the key points. If we go to the right hand side and looking at the renewable diesel side, you can see the specification for flash point 55 in 15940. We're 75. The cetane numbers very good. The FAME, obviously we don't have any FAME in this process, we're not a FAME process. Sulfur 1.5 ppm. If you look at the aviation fuel on the left hand side, you see one of the key points in aviation fuel, as you all know on this audience, is actually its cold flow properties, and getting that freeze point down to -47 is absolutely key. Flash point is also key. Many other challenges in ASTM. So our strategy as a company is to commercialize this technology on diesel, and at the same time, in parallel, run through with our partners, run through the ASTM ASTM process for tier alpha to start with, which we're through now at the moment, and go for a blend fast track option for the aviation fuel. Now, all of you on this audience that are familiar with the legislation and regulations and the time it takes to get that ASTM accreditation, even as fast track, will know that that's probably going to be 2 years plus to get that in the market. So the idea is that we would commercialise this on diesel first with some of our partners, and we'd get that moving into the market. So I'd just like to focus on the aviation fuel at the moment, because there's a great deal of help that we're getting throughout, particularly in Europe, and it will happen in the UK in the near future as we're here. So if we go to the next slide, it is a bit of a technical slide. I did say, well, I'm going to share some technical data. You don't need to look at that slide in any detail. What it shows is the black dots, the black squares, is actually our aviation fuel. So it's the Green Lizard product. The coloured slides, the coloured shapes, like the A1 is the different types of fuels that are being tested for aviation fuel. So the top one, A1, it's in the ASTM regulations, the annexes. If you look at A1, that's a Fischer-Tropsch. To give you some idea, the HEFA is the hydrogenated Thames. So what this slide shows is that all the different types of chemicals and makeup of the hydrocarbons in all of those fuels, you can see a fingerprint for us. We're quite different from a lot of the fuels. Very high similarity to Fischer-Tropsch, but of course we don't do Fischer-Tropsch. So I really wanted to share this slide with you as work in progress. And I thank very much the JetScreen group in Europe under Bastian Ralph for doing a lot of great work for us on this and helping us understand the chemical composition of those feedstocks. So if we move on to the next slide, please. So where we are with SAF, and obviously it comes down, it's very, very similar for the diesel. The tier alpha results look very promising at the moment. It looks a reasonable product. We're doing a lot of modelling now with the JetScreen group in Europe, and we're doing a lot of work within the UK now. We're seeming to get our act together pretty well now. Trace metals are all less than 1 ppm in our process. And where we are at the moment, we've just decided to build the first plant in the UK. We were waiting for the output of the Freeport status of sites. So at the moment, Teesside is our favoured site. We're pushing ahead with that. We should actually be operational in Q1 2023 for the 20 million gallons. Longer term. So that plant is funded by us. We're not looking for any partners in the first plant. We're just looking for off takers. About 30% is off taked already from that plant, because obviously when we're putting funds in, we need off takers to make sure that we sell the product. Longer term, we're looking for partners and investors to facilitate this development, and particularly off-takes and co-investment when this technology is run out. We have always worked, and it's obviously my personal background in the oil and gas industry, that making sure that the technology is at a scale that's reasonable and at a scale that's proven before we start talking about off-takes and start talking about markets. So at 7.2 million gallons running since 2017 and doing the upgrading, we feel now is the time to actually get this technology visible, and really looking for help from this audience and the partners, potential partners in the audience, to come on board with us on this and help us build out the technology going forward. So if we get the next slide, it should be hopefully my last slide. Again, I'd just like to thank very much Bastian Rusch for the JetScreen in Germany for doing this project on the SAF for us. Chris Lewis, many of you will know Chris, formerly Rolls-Royce, head of aviation fuels at Rolls-Royce, now doing his own consultancy. Our colleagues at Corriton, ITS, Intertech for doing a lot of the analysis for us. And thank you all for listening. Thank you.
Martin, thank you very much. And thank you to all the speakers. The timekeeping's been impeccable with very little intervention, and those were fascinating talks. So that's wonderful. Also thank the audience, because the chat box hasn't been too frenetic, and I think I've been able to look at the questions as they've come in. There's one person who's got a hand up. I don't know if they mean to have their hand up, but I think it's better if you just put, if you've got a question, to put it in the chat box, because I won't be able to go to you to deliver a question. So great. So okay, I'm going to take some of the sort of questions to the speakers first, and then widen things out into more of a panel discussion. Perhaps all the speakers would like to switch their videos on. Thanks, Chris, you've got yours on. There was a question, actually a question from Gloria, who asked Chris, but I think this question applies equally to other project developers, what the greenhouse gas savings associated with the fuel that you're intending to make are likely to be, if you can share that. If you can all share that.
Yeah, okay, I'll give you my response. Obviously, you know, there's a minimum you need to meet in terms of 65%, and then I think it becomes a question of the economics in each of the options. I think, you know, a lot of the projects, you know, some of them, whether it's hydrotreating or gasification, they need hydrogen. I think, again, when you look long term, you've got to really consider where the green hydrogen is coming from, and that's heavily influenced by cost of power. So I think all I would say is I'd be very uncomfortable if it was only at 65%. So I want it to be as high as possible. And then I think it comes in terms of, you know, when in a project's, I don't know, duration, as when it needs to hit the lowest GHG level it can achieve. So I'm a little bit, I know I'm probably a little bit vague in the response, because each feedstock and each technology has different parameters, but we do look at quite a lot of the scenarios to consider whether we think the project is viable, but it has to be on the basis of ultimately green hydrogen and green power.
Yeah, so somewhat of a movable feast, but that is the case with this. So many things can be innovated. There's so many improvements that could be made iteratively, which is quite unique. So, Simon, did you have any equivalent info to share? Or
yeah, I mean, it is a moving target, and it is, you know, difficult to calculate and summarise. But, you know, rough numbers for us is, you know, 80%, and our plan is to get to at least 90% with carbon capture, and then green hydrogen on the top of that should improve further. But, you know, yeah, it's that getting from 90% to 100%. You know, you're going to require something else.
Mm-hmm. Great, Martin, did you want to add?
Yes, on our process at the moment, the base case, we're about 85% carbon saving. If we add the graphene as a carbon capture, we're getting much higher than that. A variant we're going to be demonstrating very shortly in the UK is the green hydrogen production from our off gas, which will take us then into basically a net zero emission for that process, for that product. So very much in line with what Chris and Simon have been saying there. I think we all see movements beyond 85, 90% longer term as being the real target.
Bring back the greenhouse gas saving regulations, eh? That would be a helpful driver in that direction.
Certainly would. Yeah.
On an optimistic note, there's a question for you, Ollie, in the chat box. I don't know if you've seen it. I think my interpretation of that question is, if these fuels don't meet EN 590, could we just pick a different standard? What would you say to that?
No, that's a very good point, actually, and I actually meant to mention it There is another spec, which is EN 15940, which is the spec for paraffinic diesel, and it's been created really for this kind of product. So it fits the definition of the HVO, but also Fischer-Tropsch diesel, whether it's BTL, GTL, CTL. So Fischer-Tropsch diesel coming from respectively biomass, gas or coal, and probably in the future it will apply to e-fuels as well when e-fuels become a reality. And I think I'm not entirely sure, but I believe that the companies who are selling R100 at the pump, for example, I think Total is selling R100 in the Netherlands in a couple of petrol stations, are using that spec as part of the regulatory framework to sell the product. So anybody wanting to sell 100% renewable diesel at the pump today would have to look into the possibilities offered by EN 15940. But if you're a fuel supplier and you're supplying a retailer, like a dealer group, for example, Euro Garages or MRH, other brands are available, by the way. If you're supplying these people, your contract with them will be on the EN 590. So you'd have to make a different arrangement in order to be able to sell R100. So the point is valid that this other spec does exist. I think people would have to look into the practicalities and the regulatory aspect, and the impact on engine warranties, etc., of using that different spec.
Yes, I've heard people say that many OEMs on the heavy goods vehicle side do warrant for
the truck OEMs, I think do, yes, but clearly passenger cars is another matter.
Yeah, sure. Okay, I'm going to read another question out here. It's a bit of $1 million question, perhaps. Emerging feedstocks. That is always an issue of great interest, particularly if people kind of find new sources of feedstocks they don't think people are onto. But a question for all of the speakers from Keith Simons. What do you see as emerging feedstocks, and what will really grow their share in the future? Any thoughts on that?
I'm happy to have a go, as it were. So I mean, I think feedstocks like waste, agricultural biomass, or energy crops, that's not novel anymore for me. Those feedstocks are well understood. Municipal solid waste is now well understood in terms of how it can be used and the economics around it. I think what's interesting right now is because there is such an interest in hydrogenation of lipids, people are starting to look deeper and deeper into new type of feedstocks, which are effectively oil feedstocks for hydrogenation. So you're looking at some of the novel crops like camelina, for example. You're looking at some of the intercrops, so crops that can be plants that can be grown between the main crops on a piece of land, and therefore have a much lower impact on greenhouse emissions and land use change in particular. And also other types of waste lipids, such as bleaching earth from the pre-treatment of oils, of edible oils, for example. So I think people are becoming more and more innovative in the way they look at those waste lipids. The holy grail for me remains algae. So oil coming from large-scale algae. Whether it will ever happen, I certainly wouldn't want to call it, but that could be the holy grail in terms of growing biogenic feedstocks on ponds, on the sea, wherever, or in the desert, and not use arable land in doing so.
That's very interesting. I just want to add, Chairman's privilege, one more to the list, actually, on the lipid side, is just preventing grease from entering the sewage system from the food services.
Fatbergs.
They catch the fatberg before it gets down there and starts growing, is something that really we should be doing better in this country. And we're the RTFA is contributing to a guide that's coming out on that. But it is pretty poor how we manage that in this country. Simon, did you have any other?
A few comments to make. I think Ollie is far more expert on this subject than I am, but yeah, just on the the fats and oils that are being thrown away at the moment. You can see it in the market. With restaurants closed down, and the amount of the very limited amount of used cooking oil that is available at the moment is very apparent. People are still using oil and cooking. It's just not being collected. There's still a huge potential to collect and aggregate used cooking oil. So I think there's room to go there. All the things that Ollie mentioned, I completely agree with. I think something that we're focused on is Fischer-Tropsch type processes and integrating carbon capture and green hydrogen. I think that for us that's kind of the holy grail. Yeah, and along with all the other waste, there's still a lot of waste. We're producing more and more waste. Still more to do on plastics and recycling plastics into fuels. So there's plenty to go after.
Yeah, Chris.
Well, I don't know whether it's controversial or not, other than I think it picks up a little bit on Simon's comment. Is I'm not necessarily convinced we have proven yet the sort of RDF, MSW gasification into fuels. There's not enough. There's not enough reference. So I think the one thing about there are potentially other feedstocks, but let's seize the opportunity to prove that we can divert RDF from, I see some of the comments. You don't want to go into incinerators, with heat recovery and low power generation. They need to be diverted, through gasification or pyrolysis and syngas, and whether it's Fischer-Tropsch or it's other biogasoline, biodiesel or SNG, that's a much better alternative. So I think it's also, you can see with some other projects, I think you've got in your SAF sort of webinar, is projects are seeking funding, and that's something we probably need to focus on to make sure those feedstocks that are available now and can be proven do deliver projects that bring those fuels to market.
Yes, I noticed there have been a lot of comments in the chat box of that, triggered by Andrew Fraser at the very beginning when I was mentioning about, it really makes sense to divert things or to build fewer energy from waste projects in the future. Now there's a better carbon saving option. So as to whether you'd want to divert from wood pellets from Drax, I think that's probably one where you've got the potential for the carbon capture there. So, but there's so much to go on, and we really need to question the new ones, of which there are many coming through now.
I think the thing, Gaynor, I would just add there on the biomass side is we're looking obviously at volumes. So we're looking at feedstock supply into volumes of product that we can get out. So a couple of things that we've noticed very recently, and a lot of interest in Asia. We've got a lot of palm oil wastes, EFB wastes. They're about $25 a ton at the moment. 90 million tons of that in Malaysia alone. Indonesia is a larger base. In Brazil, the bagasse is a huge market, 300 million tons of bagasse. And I think, as Chris was saying, when we look at proving the technology on proven feedstocks, there's a lot of feedstock out there that can bring substantial amounts of products to market, and actually on our, literally on our radar screen. Yeah,
I couldn't agree more. We'll hopefully be publishing a study that we commissioned really to look at just that, to try to give DFT confidence that they can increase the renewable transport fuel obligation target significantly, because there's the sustainable feedstock around to justify it. And on that note, Gloria, is there anything that to mention on a website that we were expecting?
No, not that I've seen.
I'm hoping to make to mention something, but we may run out of time. Right. Well, there were. I just want to ask a question on the government's plan to consult on the ending of HGVs, new diesel HGVs. How do you think panelists, do you think that might pan out in reality? We've not had the consultation yet. I've been very much hoping it's going to be technology neutral and looking at the end result you want to achieve, which is, you know, low carbon kilometers driven or whatever, rather than saying this technology shouldn't happen. But how do you think it's actually going to pan out in reality? Anyone want to kick the ball off with that for that one?
Yeah, interesting. Again, it's probably one of those questions I'm not quite sure how it will pan out. I think, as always, you've just got to prepare for what could be the different outcomes. I would hope the consultation is truly objective and does consider, you know, the evidence appropriately. You know, we do, as we said, you've got existing infrastructure and fuels, and the increasing blends of low CI fuels. You'd want to maximize that before, and obviously there's opportunities in terms of SNG, etc., which again leverages infrastructure before you have to consider what you need for hydrogen. So I would, as long as there's a wide enough call for evidence, then I think, you know, as far as what you have to consider, one has to consider, well, what happens if that ban does come into play? That will potentially, you know, I think it's similar to what we've discussed in how people will consider projects to bring forward renewable fuels. If that consultation could have an outcome, then those projects won't happen. So again, I think probably into the consultation, we need to make people aware, if in the event a scenario came forward that wasn't truly objective, an unintended consequence is certain renewable projects may not come forward because they won't have sufficient duration before the alternative. So probably haven't answered your question other than immediate response that just brings forward a lot of uncertainty.
No, it's a fair point, and I was thinking of asking a question about kind of the impact on investor appetite, I suppose, of the kind of like the messaging coming from government on banning diesel this, and just generally kind of just lack of, you know, a recognition of the roles that fuel can play. You know, how does that?
I think that's the key point indeed, Gaynor. And I mean, I think most of us on this call would probably be voting for technology neutrality. I mean, that's the crux of the issue. And clearly, banning ICE in trucks is not technology neutrality. Now, at one level, you could look at it and say, well, it's forcing an outcome, but if the outcome is good, you know, why not? The problem is, too often people are thinking in terms of false dichotomies. So it's like it's a choice between liquid fuel and electricity, or it's a choice between putting the fuel into a truck or putting the fuel into a plane. I mean, the reality has to be much more sophisticated and much more nuanced than that. And it's using that principle of technology neutrality to absolutely optimize all the uses of low carbon energy that we have. So of course, electricity has a big share and should be driven. But what happens if you only focus on electricity is you're going to kill some projects which would have been liquid biofuels projects, I mean, which would have been needed for the jet market in any case, because I think most people are coming to the conclusion that it's going to be very, very difficult to displace liquid fuels in aviation. And if you kill some of those projects, the shame is that a lot of the projects that we are looking at now have got almost dual mode, or have got quite a lot of ability to switch to max jet mode and max diesel mode. And they could perfectly well produce in max diesel mode and decarbonize the truck sector faster and then go into jet. So I think the problem with those preemptive choices is that they are killing investment, or there is a serious risk that it would be killing investment, which would have made sense in the long term anyway.
Does any other speaker want to add to that?
Yeah, I mean, I'm not going to get into the politics, but they may have already made a decision. I don't know, but the key is exactly that, is technology neutrality, and they've got to look at transportation as a whole and think about all those different sectors, to Ollie's point, and think about the capital stock of aeroplanes. They turn over, what, 30-year lifespan, ships 25 years, cars 15 years, trucks 5 years. So that needs to come into it as well. And I think with trucks, you've got an opportunity to apply neutral technology solutions to it, and as the market evolves, as the energy supply evolves, then you can pivot and change direction. But narrowing that focus at this point is completely the wrong thing to do.
Yeah, well, I think we're all preaching to the converted, aren't we? All in violent agreement on that point. And I mean, I don't know if anyone's got any suggestions as to just how to make this this sector, what we're doing here, more visible. Any thoughts on that? I mean, one of the things, I mean,
I think it's probably more about demonstrating how good our products are with the whole supply chain and end users. I think because a lot of these technologies are small scale, you can't get sort of 100 tons, 1,000 tons, 200,000 tons to even get a fleet trial going. But I think once you've got large volumes of materials there, and you can demonstrate the GHG savings, you can demonstrate the carbon intensity reduction, I think will go a long way into getting us more visible.
Right. Well, we've got 3 minutes left of our allotted time here, so I should probably, with regret, call this this discussion to a bit of a to a halt, because we've got to mention the other to thank the speakers again and mention that we've got the other forthcoming events. So, Gloria, did you want to just put, have we got dates for the other meetings and any further things we want to say before we close?
Yeah, thank you very much, Gaynor. Yeah, it's just to make everybody aware that we've got 2 more webinars in this series. So next Wednesday, the webinar will be on advanced renewable gaseous fuels. So we're looking at bio-SNG, biomethane and hydrogen and biokerosene. Biopropane, and then the next day we're doing sustainable aviation fuel. So you can find out more information about those webinars on the Eventbrite page. So I'd just like to finalise by thanking Gaynor and thanking all our speakers very much today, and thank you all for coming. The webinar will be made available in the next couple of days if you'd like to hear it and see it all again. So thanks a lot and goodbye.